Hello, everyone, and welcome to Rules for Differentiation B. So we're going to start off the same way as last time. I just want to remind you that there are several ways of writing the same thing. So y prime means derivative, f prime of x means derivative, dy dx means derivative, and all these things mean the slope of a curve at a point. Okay, or you might want to think of it as the formula for the slope of a curve at a point. Okay, but when you think derivative, you should be thinking slope. That's what it's telling you. So on 1a, you might be looking at that thinking, well, I could just multiply that out and then I could find the derivative. Absolutely. But I'm going to give you much, much more challenging problems in the future where you're going to need to know this thing called the product rule. But I'm going to teach you on 3 really easy ones. So the product rule says that you have a function u. I told you calculus loves u and v. So you have a u and a v. So the derivative of the function is going to be using this formula, v, which is 2x plus 5, times the derivative of u with respect to x. So this is u. And if I take the derivative with respect to x, that means x is the thing you're doing things to. So 3 plus u, which is 3x minus 1, times the derivative of v, which is 2. That's the product rule. I'm going to simplify that real fast. Plus 3x minus 2. Oops, not 6. 6x minus 2. And that gives me 12x minus 13. That's the derivative. Now, could I have multiplied it out? Absolutely. Y is equal to 6x squared. Outer is 15. Inners is negative 2x, so plus 13x minus 5. Derivative is equal to 12x plus 13. How did I get plus 13? Oh, because it is plus 13. There you go. That was a good check then. But the point is, would that the green way would have been faster? Absolutely. But we don't want to always have to do that. You're going to have problems in the future that are things like y is equal to e to the x sine of x. You're not going to multiply those together. You're going to have to be thinking product rule. So go ahead and do the next 2 on your own. I will put the answers here for people that are just checking really fast. Y prime is equal to 5x to the 4th plus 3x squared plus 6x. Letter C is y prime is equal to 4x plus 7. And letter D is y prime is equal to 2x plus 2. But now I'm actually going to do them for you. Okay? So the way I like to think about it is instead of using V's, I'm always going to call it the first and the second. So V is always the second one. So it's the second times the derivative of the first plus the first times the derivative of the second. In my opinion, that's just easier than u and v. So that gives me 2x to the 4th plus 6x plus 3x to the 4th plus 3x squared, which gives me y prime is equal to 5x to the 4th plus 3x squared plus 6x. Letter C. I've already written the answer. Now I'm actually going to do the problem. Y prime is the second times the derivative of the first plus the first times the derivative of the second. Next step is to simplify. 2x plus 3 plus 2x plus 4. Y prime is equal to 4x plus 7. Hopefully you're getting the hang of it. Last one. Y prime is equal to the second times the derivative of the first plus the first times the derivative of the second. Y prime is equal to x plus 3 plus x minus 1. Y prime is equal to 2x plus 2. Great, that's the product rule. Next up is the quotient rule. So sometimes you'll have two things that are being divided by each other. So now the top is going to be u and the bottom is going to be v. So this one, using my same little way of talking about it, I always do the bottom. I know this is terrible technical language. I hope my boss doesn't watch this video. The bottom times the derivative of the top. So u is always the top and v is always the bottom. So the bottom times the derivative of the top minus, this is where people go wrong, minus the top times the derivative of the bottom, all over the bottom squared. So y prime is equal to 2x to the third minus 2x. Here it comes. This is where the mistake is. You need to make sure you distribute the negative. So distribute it when you distribute the 2x. So this is going to become minus 2x cubed minus 2x. And then your final answer would be the 2x cubes cancel. So minus 4x over, and there's no reason to multiply that out. That's considered a perfectly acceptable way of writing it. If you think you completely understand the quotient rule after just one example, you are more than welcome to just look ahead. I'm going to write the answers off to the side here. Y prime is equal to x to the fourth plus 2x over 1 minus x cubed squared. Of course, when you're filling in your notes for me, you better be showing all the work. The answers only are just if you're skipping ahead. All right, let's do these out. So y prime is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. I distribute. No distributing the negative this time. It's just a minus times a minus becomes a plus. 3x to the fourth. Don't be lazy. I know you don't want to keep writing this denominator. These problems are long. You have to do it. And that gives me x to the fourth plus 2x over 1 minus x cubed squared. Hopefully you're getting the hang of it. Last one. Y prime is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Negative 1 minus x squared. I'm distributing that minus 1 from the back side. And now I'm going to distribute the 2x and the negative at the same time. So negative 2x. And then when I distribute this to the negative x, I get negative 2x squared, but I'm going to write positive 2x squared. Again, don't be lazy. You want your work to be accurate on each step. So what does that give me? X squared minus 2x minus 1 over 1 plus x squared squared. box it and call it a day. I love these. Okay, so now you've learned two rules, product rule and quotient rule. This next one, the book gives its own special name, negative integer power rule. I have to tell you, I think you would have done this regardless. It's just saying that you, even if it's a negative number, you can still bring down the n and still subtract 1, even if n is a negative number. So a little reminder about this form. This is saying the derivative, that's what that d is for, the delta, the derivative, the change in slope, with respect to x of, the parentheses mean of, x to the negative 5. You just do it like you always would. Negative 5, x to the, you just have to be more careful, negative 6. Or negative 5 over x to the positive 6. Okay? Both are good. So what's really important is when you just have a constant on top, I cannot stress enough that these problems will be so much easier to bring that to the top and give it a negative power. That's easier than quotient rule. Don't use, I mean, it's not that you can't, but don't use the quotient rule for some kind of constant over a variable. Okay, it's just much easier to do it this way because now y prime is just 2x minus 2x to the negative 3, or y prime is 2x minus 2 over x cubed. Keep in mind, only the x cubed would go to the denominator. The 2 does not have a negative exponent, so it would stay at the top. So this next one is really hard for a lot of kids for algebraic reasons, not for calculus reasons. So you could use quotient rule, or I'm going to show you how to do it again like we did with B. I would bring it to the top, but I would change it to a negative 1/2. So it's negative because it's on the top, and square root and 1/2 mean the same thing. And then I would distribute that. So x to the 1 times x to the negative 1/2 is x to the 1/2. And then 1 times x to the negative 1/2 is x to the negative 1/2. And now this is not so hard. 1/2 x to the, be careful, what's 1/2 minus 1? Negative 1/2. And same thing here. What's negative 1/2 minus 1? Negative 3/2. Okay, if you're in the honors class, you did your job. You simplified, not simplified, you found the derivative. Done. You can box your answer and stop here. However, if you are in the AP class, this problem is not going to come up on an open-ended section. It's going to be in the multiple choice. And I guarantee you this is not going to be one of the multiple choice answers. So let's talk about what the multiple choice answers could look like. And honors, this is still a skill you're going to have to develop. So you're still going to want to watch this, but if you don't develop it today, that's okay. So think about factoring for a second. If you factor x 2x cubed minus 3x to the 5th, what can you take out of those? Hopefully instantly you're like, well, x cubed. You don't bat an eye at that. You know instantly which one you can take out. How do you know? You always take out the smaller exponent. You can't take out the larger one because the x cubed doesn't have it. So the same is true for our problem. Which number is smaller, negative 1/2 or negative 3/2? So I can take out the 1/2 and I can take out the negative 3/2. Okay, this is hard stuff. What exponent goes here? If you take out a negative 3/2, what's left? 1. Because 1, which is 2/2, minus 3/2 is negative 1/2. And on this one, you took out everything. You still would not see this. Ooh, Ooh, terrible, terrible. Derivative. You still would not see this as an answer on a multiple choice question. You would see an x minus 1 on top and a 2, that's in the denominator, and x to the positive 3/2 is in the denominator. There's a chance you would see this answer. This is one good answer. Another good answer, though, is to multiply, or you could see multiplying the top and the bottom to make the bottom rationalized. So if you multiply the top by x to the 1/2 and the bottom by x to the 1/2, that's what you need. You need another 1/2 to make that into a whole number. That would give you square root of x times x minus 1 over 2. Now this is 4/2, which is x squared. That's a pretty complicated answer there. So this is what's going to start to happen with derivatives. When you first start, hopefully you're saying, this is easy. Product rule, power rule, quotient rule, piece of cake. It's the algebra. It's why I was so torturously mean to you for the last couple of years, because this algebra is precisely where people get stuck in calculus. There's a saying, calculus is 10% calculus and 90% algebra. And it is true, in my opinion. All right, power rule expanded. So what this means is when you want to take the derivative, not just of x to the 5th, so if I gave you y is equal to x to the 5th, well, then you know that y prime is 5x to the 4th. So now we're going to expand that concept. If you have more than just x, if you have a whole polynomial to the 5th, you can't just do the whole polynomial to the 4th. I mean, you can, n, u to the n minus 1, but then you have to multiply it by the derivative of u. So this is your u. You're going to multiply now by the derivative of u with respect to x. Now there's at least one of you in the class who's saying, why? Why does that work? I'm just going to multiply this together. So I am going to explain why it works, just not today. Today, our goal is going to be just to actually do the problems. And then the theory behind it, this is a lot of how I'm going to teach this here. Let's master the mechanics. And then when I go to do the theory, you won't be busy trying to get the mechanics also. Okay. All right, so let's try that again. This time f prime of x. So I still bring down the 3. I still do x squared plus 1 to the 2 as if it was just any other problem. But then we multiply by, and people throughout the country, world maybe, call it times the derivative of the inside. Okay, they call that the derivative of the inside. So that's not just a South or a Miss Shaffer thing, that's everybody. And so the derivative is 6x times x squared plus 1 squared. Okay, so you pretty much start it the same way, and then you do the derivative of the inside. Next one. Now notice I'm jumping straight to the equal sign. I don't need to write y prime or f prime. This notation means the derivative of x minus 1, the quantity squared. So I'm going to write 2 times x minus 1 to the first times the derivative of the inside, which is just 1. So this becomes 2x minus 2. Okay. Honors, you may, I have a little note on my paper that now you can do 1 through 9 of derivatives B. 1 through 9 of derivative B worksheet. Okay. All right, ready for it to get more challenging? Here we go. We are about to use product rule and the power rule at the same time. So this whole thing is u. This whole thing is v. So I have to use product rule. Product rule says you're going to do the second times the derivative of the first. So what's the derivative of the first? 3 times x squared plus 1 squared times the derivative of the inside. So this is v, and this piece is the derivative of u with respect to x, plus the first, x squared plus 1 to the third, times the derivative of the second, 2, x minus 1 to the first, times 1. No, you don't have to keep writing that 1. Neither one of those ones do you have to write. But this is the example, and I'm trying to make sure everybody's clear. U times the derivative of v. I know there's a couple of you who are like, that wasn't so bad. I get it. It gets worse. Okay. You can't leave your answer like this. You have to simplify it. But this is so important. You do not want to simplify by expanding. Do not simplify by expanding. That would be death. It would be awful. Can you imagine raising this to the cube, multiplying x squared plus 1 times x squared plus 1 times x squared plus 1, and then times 2x minus 2? It would be terrible. Instead, you're going to want to factor out. So we are taking factoring to a whole new level. So you have two terms, one term plus another term. We're going to look for things that the two terms have in common. So they both have an x plus 1, x minus 1. So I'm going to take that out. X minus 1. This one has 2, and this only has 1, so I can only take out 1. Okay? They both have an x squared plus 1. What is the most that they have? X squared plus 1 squared. This one has 2. This one has 3, but this one only has 2, so you can only take out at most 2. What else do they both have? They both have a 2. So I'm going to take the 2 out. I'm going to actually put the 2 in front. And that's it. I don't see anything else I can take out. So now I'm going to put a big bracket, and I'm going to look for what's left. So with the x minus 1, I only took out 1, which means that there's 1 left. I didn't take out the 3, so there's still a 3. I took out both the x squared plus 1s. There's 2 of them. I took out of them both. But I never took out this x, so there's also an x. That's the first term. Okay? Just like any other kind of factoring, if you did 3x plus 12, if there's 2 terms to start, there's going to be 2 terms in the end. Right? You have what you took out, you have your parentheses, and then you still have 2 terms. Here's what I took out, here's my first term, and here's my parentheses. So now on the next one, I look and I say, oh, x squared plus 1 cubed, I took out 2 of them, so there's still an x squared plus 1. I took out the 2, I took out the x minus 1, and the 1 doesn't matter. So I'm done. I still have to simplify. These are all factors. I can just leave them. But this mess I have to take care of. Now, I do get a little tired at this point of writing all these steps, so I tend to just multiply this tiny right above it. So 3x times x is 3x squared minus 3x. And then this one's x squared plus 1. So I'm not gonna make that its own step. But 3x squared times plus x squared is 4x squared minus 3x plus 1. That's the last factor. And I changed it back to parentheses just because it looks a little nicer. Really, really hard problem. If you understood it, oops, plus 1, there's a 1 there. Awesome for you. okay? It was by far one of the hardest things we've done so far. Okay, in this next section, you really should try to do as many of these on your own as possible, and then come back and see if you get them right. But obviously, I'm going to keep doing every single one of them because that's the whole point of these screencastifys, is for you to be able to look at this and then find out how I did it. Okay, and I'll box the answers at the end. So on number 1, my first step would be to change it. You might have used quotient rule. You can do that, but I personally think it's easier to change it to x squared minus 1 to the negative 5. Whenever I have the form some constant over a power, I always move it to the top and make it negative. And now my derivative is pretty easy. I get negative 5 x squared minus 1, be careful, to the negative 6 times the derivative of the inside, 2x. That's what we're going to call that. The derivative of the inside. You are required to simplify. So your final answer would be negative 10x over x squared minus 1 to the 6. Number 2, you can jump straight to the answer. There's no y prime or f prime. They're saying, what is the derivative of this? So over the years, we've tried this a bunch of different ways. Some people think, excuse me, some people think, oh, I'll separate it into 2x minus 1 cubed over x plus 7 cubed. I've done it that way, and then I've used quotient rule. Some people change it to 2x minus 1 cubed times x plus 7 to the negative 3, and then they use product rule. And that's also good. There's really no perfect way, but after having done this exact same problem for years, I would say it's just 1 step or 2 steps shorter to just do it the way it is. Bring down the 3, rewrite this problem, 2x minus 1 over x plus 7 to the second, and then do the quotient rule when you go to do the derivative of the inside. So the derivative of the inside would be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So I think you might have heard me say in the last problem, I'm not willing to rewrite the entire thing, so I just kind of go like this, in a different color, 2x plus 14. And this is going to be minus 2x plus 1. And it saves me a little tiny step. Now, in order to put these together, I am going to do what we looked at up there, 2x minus 1 squared and x plus 7 squared. And this numerator is 15, and this denominator is x plus 7 squared. That's 15 because the 2x and the minus 2x cancel. When you have a number, but everything else is a fraction, you can change the number to a fraction. And then you can multiply straight across the top and straight across the bottom. And now you can see why I broke it down into 2 separate, a square on the numerator and a square on the denominator. Let me just check my answer, make sure I got it right. Woohoo! All right, let's do number 3. So number 3 is highly missed on quizzes and tests. There's one definitely just like it. Pretty much if you ever think you need quotient rule and product rule in the same problem, you're probably doing it wrong, or probably could have done it easier, I should say. So watch what we're going to do. I'm going to rewrite it. I'm going to FOIL that out. So first, outer, I'm going to do inners first. That's not first. First, outer is going to give me minus 2x squared, inner minus x squared, and last plus 2x. First, outer, inner, last, over x to the fourth. Notice I keep writing y is equal to. Your labeling is going to be very important to me because at some point you're going to change it to y prime is equal to. So this is going to give me x cubed minus 3x squared plus 2x. So what I can do is I can factor out an x and cancel it, but even better, this is the key step, I would divide each of them by x to the fourth. So I would make this x to the negative 1 minus 3x to the negative 2 plus 2x to the negative 3. When I simplify first, when there's a monomial in the denominator. So whenever I have a monomial, meaning a single term in the denominator, I apply that to each of them, and now it's an easy problem. So remember, these are all y. Now I'm going to switch it to y prime is equal to negative x to the negative 2 plus 6x to the negative 3, just using my power rule, minus 6x to the negative 4. Don't leave your answer that way. Write it like this, 1 over x squared. The 6 stays on top and the x cubed moves to the bottom. The negative can go out in front, and your answer will look like that. So that's definitely a trick that you're going to want to know to make your life easier. Multiply out and then apply that denominator to each of them. Do not try and use product rule and quotient rule in the same problem. It'll be awful. It'll work if you do it correctly. Okay, so number 4 makes me very sad because this is, I'm usually walking around the room and some people are going to do this with the quotient rule and they're going to do this really big, long problem. And then this is usually an opportunity for me to give big smiles to the kids that think of something first. Can you think of something first? Come on, look at it. Simplify first. Always simplify, but even differently than the way we'd simplified the last one, this one factors. This is x plus 2 times x plus 5. This is just 1 over x plus 5. How easy is that derivative going to be? So you might remember that I said personally, when there's just a monomial on top, I choose to move the entire denominator to the numerator and give it a negative exponent. I think that's easier than quotient rule, but quotient rule will work, and I'm not going to stop you from doing it. So now, remember, I've labeled all of these y. Make sure you label your work. I will not give you credit for erroneous labeling. Now y prime is negative 1 x plus 5 to the negative 2. Y prime is negative 1 over x plus 5 squared. And if you did it a different way, you still should have gotten the same answer. Number 5. Number 5 is just to make you feel good before we get to the end of this lesson. Literally, 8x cubed minus 21x squared. It's just a little feel-good problem that I threw in there. But on the first day of derivatives, remember learning this? I had to think about it for a couple minutes. Boom, just like that. If you wanted to do the second derivative, I know it doesn't ask for it, but you just keep going. 42x plus 4. Third derivative, 48x minus 42. Fourth derivative. Okay, we will do all this stuff, but hopefully not with ones that have quotient rules and product rules. Anyway, just a nice little throwback to stuff we learned before. Okay, we're going to end with a very different problem. So if you want to know the derivative of u times v, the basic rule says that it's the second v times the derivative of u with respect to x plus u times the derivative of v with respect to x, or vu prime plus u v prime. So some people like the du dx because they can see it better. Those little primes can get lost. So if I wanted to know the derivative at 2, I would plug in a 2. So if I had this one and I suddenly wanted to know the derivative at 2, I would change the way it looked from y prime. I would change it to f prime of 2. And then I would plug in 2. That's what that means. So on this one, they're saying find the values for the derivatives at 2. So I really want it to look like this. V of 2, u prime of 2, plus u of 2, v prime of 2. And they gave us that. That's what's up here. So sometimes you're not going to have a function. You're just going to have a theoretical question. So v of 2 is 1. U prime of 2 is negative 4. Let's see, u of 2 is 3. And v prime of 2 is 2. And negative 4 plus 6 is 2. All right, you can go ahead and try those on your own. If you're skipping ahead for the answers, B is negative 10. C is a little tricky. They put V on top and then U on bottom. So watch out for that. And D is negative 12. Once you get those three, you can go do derivatives B. You're ready. All right, so I'm going to do these last three for people that did not get them right. So this is the quotient rule. So we're going to have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, they actually want to know it at x is equal to 2. So now I can rewrite that as v of 2, u prime of 2, minus u of 2, v prime of 2, all over v of 2 squared. Now I just fill in the numbers. So v of 2 is 1, u prime of 2 is negative 4, u of 2 is 3, v prime of 2 is 2, all over v of 2, which is 1 squared. So negative 4 minus 6 is negative 10 over 1, which is just negative 10. So I think letter C is honestly, just to be a little mean, they switched the U and the V. This is why I personally always call them the top and the bottom. So this is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And then at x is equal to 2, this is the exact same thing, but now I'm going to take each of those and write at 2. So v of 2, u prime of 2, all over u of 2 squared. And then I fill them in. U of 2 is 3, v prime of 2 is 2, v of 2 is 1, and u prime of 2 is negative 4. u of 2 is 3 squared. That gives me 6 plus 4 over 9, 10/9. Okay, the last one's easy, but it sometimes throws people. So if you're taking the derivative of 3 times u, this is something that in the beginning you never would have questioned, but now that we've done so many things, you forget some of the basics. The derivative, if you have y is equal to 3x, then let's just say to the n, y prime is just 3 times nx to the n minus 1. That 3 is just part of the problem. So this derivative is just 3u prime. The derivative of negative 2 times v is negative 2 v prime. But the hard one is the last one. Now you need to use product rule. Most people miss this. It's going to be the second times the derivative of the first plus the first times the derivative of the second. At x is equal to 2, this would be 3 u prime of 2 minus 2 v prime of 2 plus 2 times v of 2 u prime of 2 plus u of 2 v prime of 2. But fortunately, we actually already did this. We did in letter A. So in letter A, we already found out that the answer was 2. So I'm just going to go ahead and fill that into 2. And then u prime of 2 is negative 4. V prime of 2 is 2. That gives me negative 12 minus 4 plus 4. The answer is negative 12. You did it. That's derivatives B. Have a great day, everyone.